Hello students, welcome back to Teacher.Meenal's class. In today's session, we will be studying about Newton's third law of motion and law of conservation of momentum. So let's begin with first Newton's third law of motion. Before studying the law, let's look at a small activity. Take a plastic boat and make a hole at its rear end. Inflate a balloon and fix it on the hole in the boat. Release the boat in the water. What happens to the boat as the air in the balloon escapes slowly and why? Yes, what's the reason? Yes, the boat starts to move in water because when we blow the balloon up and then releases it, air escapes and pushes back against the balloon. So because of the air, we see that the boat starts moving in water. We have learned about force and its effect on an object through Newton's first and second law of motion. However, in nature, force cannot act alone. Force cannot act alone. It is not a single quantity. Force is a reciprocal action between two objects. So, for application of force, minimum two objects are required. Forces are always applied in pairs. When one object applies a force on another object, the later object also simultaneously applies a force on the former object. So, force is not applied by a single object, but when two objects are there, both apply force on each other. And the force between the two objects are always equal and opposite. So it is equal in magnitude, that is the numerical value, and opposite in direction. This idea is expressed in Newton's third law of motion. So Newton gave us idea about this action and reaction force. Let's see what it is. The force applied by the first object is called action force, while the force applied by the second object on the first is called the reaction force. Now very clearly you can see in the diagram two objects, object 1, object 2. So the force that is applied by object 1 is called as action force. See the direction of action force, this direction. Whereas the force that is applied by the second object is called as a reaction force. And if you see the direction of reaction force, it is in this direction. So both are in opposite direction. So that states the Newton's third law. A force cannot exist alone. Force always exists in pairs. So the statement is, whenever one object exerts a force on second object, the second object exerts an equal and opposite force on the first object. And these are action and reaction forces. These two forces are equal in size and opposite in direction. So, every action force has equal and opposite reaction force which acts simultaneously. Simultaneously means together. Now, action and reaction are the term that expresses force. Now, very often we heard action, reaction. So, what is this? So, these are basically the terms that says or that express force. These forces act in pair. One force cannot exist by itself. So this is an action force. Now which two objects you can see here? You can see hands and you can see wall. And you can see a reaction between object 1 hand and object 2 wall. What we have studied? Object 1 is an action force. Object 2 is a reaction force. Okay, so action and reaction forces are acting simultaneously together. action and reaction force act on different object. So this is one object, this is different object. Here fan is one object and wind that blows to ourselves is a different object. So it always acts on different object. They do not act on the same object and hence cannot cancel each other's effect. So suppose action and reaction force were on hand only, that is one object, or on fan only, that is one object. They could have cancelled each other. But is that happening? No. These are acting on two different objects. Therefore, they cannot cancel each other's effect. Okay, so I hope you are clear about Newton's third law of motion. Very simple. Action and reaction force, that is acting on two different objects. Okay, now we move further to law of conservation of momentum. Now what is this law says? Conservation of momentum. Okay, about momentum we have studied in Newton's second law of motion. Momentum is a product of mass to velocity. Okay, so conservation is to store. So let's see what this law has to say about. Now we will study that with the help of an equation. Suppose an object A has mass m1 and its initial velocity is u1. Look at this object A, it has mass m1 and its initial velocity u1. An object B has mass m2 and initial velocity u2. Okay, so this is given to us. According to the formula for momentum, the initial momentum is m1 u1. Okay, we have already studied P is equal to m into u. So m1 u1 and that of B is m2 u2, initial momentum. Now, suppose these two objects collide. Collide means dash each other. Let the force on A due to B is F1. Okay, so action force, first type of force is F1. This force will cause acceleration in A and its velocity will become V1. Acceleration is change of velocity. So from initial velocity U1, now the velocity has become V1. So what is the momentum after collision? Again it is a product of mass to velocity. So for object A, now it is m1 v1. So from m1 u1 to m1 v1. Now according to Newton's third law of motion, A also exerts an equal force on B but in the opposite direction. This will cause a change in the momentum of B and if its velocity after collision is V2. So now let's consider B. B force is also acting on that and now its velocity of B has changed from U2 to V2. Its mass is same, mass is m2. So what will be the momentum of B after collision? It will be m2 v2. So for B also from m2 u2 it has changed to m2 v2 and F2 is the force acting on object B. F1 is acting on A, F2 is acting on B. So F2 is equal to minus F1. Okay, because what we have studied according to Newton's law, it is equal in magnitude and opposite in direction. So because it is opposite in direction, the minus sign is there. Now let's substitute the values because we have studied F is equal to mass into acceleration. So m2a2 is equal to minus m1a1. So instead of F2, we are putting m2a2. And instead of F1, we are putting M1A1. Then A is acceleration. A means V minus U upon T. That is final velocity minus initial velocity upon time. So substituting this value in this equation, we get M2 multiplied by V2 minus U2 upon T is equal to minus M1 V1 minus U1 upon T. Now this T is common, gets cancelled. So what we have is M2 V2 minus U2 is equal to minus M1 V1 minus U1. Now what is there outside the bracket? We will multiply. So what we get? M2 V2 minus M2 U2 is equal to minus M1 V1 plus, because 2 minus makes 1 plus. So that is M1 U1. Okay, so this is what we can get is, let's rearrange the term so that we can omit this negative sign. M2 V2 plus M1 V1. Now this is minus. When it is brought this side, it becomes plus, and M1 U1, and this M2 V2 is taken this side, which becomes plus. So what we can say is the magnitude of total final momentum is equal to magnitude of total initial momentum. Okay, so no external force acting on two objects, then their initial momentum is equal to their final momentum. Okay, so coming to the statement of the law, when no external forces act on two interacting objects, their total momentum remains constant. It does not change. So this is the law of conservation of momentum. I hope it is clear to everyone. This is corollary to Newton's third law of motion. That means it goes simultaneously. The momentum is unchanged after the collision. The momentums get redistributed between the colliding objects. So two colliding objects are there. Okay, M1, M2, then collides, and the momentum gets distributed between the two objects. The momentum of one object decreases while that of the other increases. So depend which object is colliding with a greater speed or mass. Depending on that, the momentum increases or decreases. Thus, we can have another law which is the corollary as follows. When two objects collide, the total momentum before collision is equal to total momentum after collision. So before collision, what is the momentum? Same is the collision momentum after collision. Okay, so that explains few phenomena of the, or what you can say, some examples of Newton's third law of motion. The first one is recoil of a gun. In order to understand this principle, let us consider the example of a bullet fired from a gun. When a bullet of mass M1 is fired from a gun of mass M2, two object, bullet, gun, its velocity becomes V1 and its momentums becomes M1 V1. Before firing the bullet, both the gun and the bullet are at rest, and hence the total initial momentum is 0. According to above law, the total final momentum is also 0. Thus, the forwarding moving bullet causes the gun to move backward after firing. So very clearly we can see that as the bullet is going in the forward direction, the gun come in the backward direction. And this backward motion of gun is called its recoil. Okay, so action and reaction force, and that acts on the objects, and that we called as recoiling of a gun. The velocity of recoil V2 is such that M1 V1 plus M2 V2 is equal to 0. Law of conservation of moment we have already studied, or V2 is equal to minus M1 upon M2 into V1. Equal and opposite direction, so that is why this minus sign is there. Okay, so I hope it is clear to everyone. Okay, so as we see the bullet moving in the forward direction, is the gun going in the backward direction? Yes, it is going. But do we observe that like a bullet so fast, is the gun also going backward direction or reverse direction so fast? No, it is not going. So let's see what is the reason behind it. as the mass of the gun is much higher than the mass of the bullet. This we know that gun is bigger, bullet is smaller. The velocity of the gun is much smaller than the velocity of the bullet. Okay, so mass is higher, velocity is smaller. The magnitude of the momentum of the bullet and that of the gun are equal and their directions are opposite. Okay, so their magnitudes are equal and their directions are opposite. So the total momentum is constant. The total momentum remains constant. Thus, the total momentum remains constant and the total momentum is also constant during the launch of the rocket. Now you can see here the launching of the rocket. So from the back side we see the fuel. So action force and reaction force. Okay, so both these forces are acting and then because of that the rocket goes in the forward direction. So that force we can see. But what force rocket is exerting? Okay, so that is again compared to the velocity or the mass of the other object, it is smaller. So we see the rocket moving in the forward direction. Okay, so this explains all the instances or all the examples that are related to our daily life according to Newton's third law of motion. So I hope Newton's third law is very clear to you. Okay, so even the first and second law, so this is an important part of the lesson. So you have to prepare it well. Okay, now there was one small topic which is uniform circular motion. So just I will explain you quickly what is this uniform circular motion. Now this uniform circular motion is on page 9 of your textbook. Okay, so let's see what it is. When an object is moving with a constant speed along a circular path, the change in the velocity is only due to the change in the direction. So you can see that the object is moving along a circular path. Hence, it is an accelerated motion. Now, circle, do you have any direction? No, no specific direction as such. So, it's a circular path. So, when an object moves with a constant speed along a circular path, the motion is called as uniform circular motion. Okay, so example is the motion of a stone in a sling or that of any point on a bicycle wheel when they are in uniform motion. So, very simple, object moving in uniform circular motion. Okay, even the hands of the clock are also moving in the uniform circular motion. Now, let's see the formula and how it is derived. If an object is moving along a circular path of radius r, takes time t to come back to its starting point. Okay, so this is the circle of radius r and the one rotation or one full circular motion takes time t. Its speed can be determined using the formula speed is equal to circumference upon time. Okay, so circumference, that is the outside, you know about circumference of a circle. Okay, divided by time. Now circumference is found by the formula 2 pi r. Okay, where 2 is a numerical value, pi is a constant and r is the radius of the circle upon t. So we can find the speed of that by using this particular formula. Okay. Now how can you determine the direction of velocity in circular motion? Because as I told you that for a circle there is no specific direction as such. But still we can determine the direction of velocity. Okay, so a small activity is there. What you can see is, you can see a circular disc is moving and a coin is kept on that. Okay, as the disc starts moving, you will see that the coin is being thrown off in a specific direction. Now, which direction is that? Okay, or how we can determine is, the coin will be thrown off in the direction of the tangent which is perpendicular to the radius of a disc. Okay, so this is the disc, this is the radius of the disc and this is a tangent. Tangent is basically a line that is drawn at 90 degrees to a specific circle. Okay, so whichever position it is, or as the disc is moving, it is always, the coin is thrown in a tangent that is perpendicular direction. It means that as the coin moves along a circular path, the direction of its motion is changing at every point. Okay, so as the disc is moving, now the disc coin is here, so it is thrown in this direction. Suppose as the disc moves, the coin comes here, it will be thrown in this direction. Then here it will be thrown in this direction. Okay, so the direction keeps on changing, but it is always tangent, that is at 90 degrees. Okay, so a very simple module of uniform circular motion. Okay, so with this we have come to the end of the lesson. Okay, so children, this lesson is very important. There are a lot of derivations or equations in that, and you all are going to write the equations in your notebook. Okay, now notes I will be sending to your class in the PDF form. In the PDF form, I will send you the notes. The notes will include all the questions that are there behind the textbook along with the numericals. Now, objective types of questions as well as subjective types of questions, I will solve the numericals and I will give you in the PDF form. Along with that, in between the lesson, there are some questions like use your brain power or can you recall. Even that answers also I will give in the PDF form, and that everything you are going to write in your notebook. Now, I already told you about the notebook. Notebook is given to you, 100 pages or 200 pages notebook you are making. Okay, so write the notes that in the notebook. Please write the derivations, all the derivations that are there. Derivation means the chemical equations. Like for example, on page 8, you have equation describing the relation between the velocity and time. Okay, so that is a full derivation. So that you will write in the notebook. Then the law of conservation of momentum from page 15. That everything you will write in your notebook along with the numericals. Okay, so this is your teacher Meenal Pereira signing off for lesson number 1. Thank you very much. Please take care. Stay at home. Stay safe. God bless you.